Second lecture is on the product and the quotient rule. So I'm posing you a question. Is the derivative of 3x plus 2 times negative 4x squared minus 3 equal to the derivative of the first piece, which is 3, times the derivative of the second piece, which is negative 8x. So that gives me negative 24x. No, Mr. Slaughter, why? Yeah, because if we multiply it out first and maybe simplified things, we would be able to use the power rule. And this is negative 12x cubed. I'd have a negative 8x squared. I'd have a negative 9x. And I'd have a minus 6. If I took the derivative of this, I see that my derivative should equal negative 36x squared minus 16x minus 9, which is not the same as negative 24x. So what does this tell us? The derivative of some function times some other function is not the derivative of the first guy times the derivative of the second guy. Instead, and in your book you can see the proof of why this is true. I won't go through it because it's long and tedious. The derivative of two functions being multiplied together is the following. The derivative of your first guy times your second plus the derivative of your second guy times the first. Or f prime g plus g prime f. Let's go ahead and check that with this previous situation. We have, let's snip it. We have this guy. We know the derivative of this guy is equal to negative 36x squared minus 16x minus 9. Let's try to apply this power rule to find the derivative of this. Well, it's very obvious to see the product of the two things. It's very obvious to see which one would be considered my f function and which one would be considered my g function. For others, it might not be so obvious, but for this one, it is. So all I do is take the derivative of my f, which is 3. This is my f prime. Multiply it by g. And I add the derivative of my g, which is negative 8x. And multiply that by f. Now, let's see. Is that going to be the same as this? Well, I can kind of distribute things and get negative 12x squared minus 9. Here, this is negative 24x squared minus 16x. So I got the negative 16x right here. That's the negative 16x right here. I have the negative 24x and the negative 12x. That gives us the negative 36x squared. Sorry, those are x squareds. And then negative 9 gives us the negative 9. So the product rule works. Okay? So it's just kind of like a formula. Sorry. It'll also be online if you need to rewatch it. That's cool. Now, you might say, well, Mr. Messner, why did I really do that when it's easier to probably just distribute things and then take the derivative? Well, there will be functions that are being multiplied together that are not as easy. This one I could still distribute, and I could still distribute and then use the regular power rule. However, it'd be long, it'd be messy, and maybe I just want to go straight to finding the derivative. Well, using the product rule, we'd be able to do that. This guy, I cannot use the power rule. I cannot try to distribute things with x cubed and cosine x. Instead, I would have to use the product rule for this. I'll go ahead and write them down because they'll be good ones to try. This is x squared plus 2x minus 3. Yeah, that's a 3.
Wouldn't it end up taking like the same amount of time, like the f of x, to do it with the power rule?
It's a good question. It's a good question. Would it take the same amount of time? Depends. I'll show you how it might and it might not. I would say it would definitely not. So if I took the derivative of this to give me f prime, so I'm ddxing everything, we can use the product rule. So f prime is first. That is 2x plus 2. That would be multiplied by g. Plus g prime, which would be 3x squared minus 6, just the derivative of my second piece, times f. Well, Mr. Slottiger, that's your derivative. I can plug in values in for x into this, and I will get slopes. I don't have to simplify this. I can say, hey, I'm done. If I wanted to try to find f prime of 0, well, it would be a lot quicker to plug in 0 as I see it right here than to distribute this whole thing, then take the derivative of each individual piece using the power rule, right? So this brings us to a common question asked, like, is this it? Are we done? Well, yeah, we are. That's a derivative. I can plug in x's, like f prime of 0 would give me 2 times 6 plus negative 6 times negative 3, right? That's a slope, 12 plus 18. 30. So sure, that helps us. Now, in terms of maybe a quiz or a test, this is a possible answer. However, we might have to be prepared to simplify it so that we get an answer that the test question is looking for on a multiple choice test. So leave it like this on a quiz. This is fine. But most likely I'll be telling you to find the derivative at a certain value. That way you know you can just plug it in. Okay? So that's the first one. You guys try the second one. Now for the second one, step 1 is to identify what's being multiplied by what. If you need to use parentheses, do so. X cubed is being multiplied by cosine of x. Identify your f, identify your g, f prime g plus g prime f. Check with a neighbor. Should be pretty straightforward.
That's 30 for the first answer.
That's 30, yes, if I asked you f prime of 0. Questions? Oh. Now, would we possibly have to simplify this? Yeah, maybe, on a multiple choice question. Maybe they're looking for an x squared factored out, and you got 3 cos x minus x sine x. Maybe that's the only thing you're going to see. So yes, you need to be prepared to simplify something to make it look different. However, this is something that you can plug values into. Okay? So, do the following. Find the slope of the tangent to the function when t is equal to pi. This product rule really helps us be able to plug in values. Make sure we separate things into an f and to a g. Yeah, those x's in the first function are supposed to be t's. That's my bad. All right, check your answers. Any questions? Mr. Robertson, what'd you get for the first one? And what'd you get for the second one, Mr. Ruzicka? Okay. What'd you get for the derivative of the second guy? Careful. F prime. What's the derivative of t plus 1? 1. 1. So it's 1 times sine t plus the derivative of cosine is sine. Derivative of sine is cosine times t plus 1. This is my f. This is my g. This is f prime g. This is g prime f. Plug in pi. The sine of pi is 0. Cosine of pi is -1. This should be negative. Sorry. Yeah. -1 times pi plus 1 would be negative pi plus -1.
Oh.
And the first one would be -2.
Okay, I just didn't distribute that.
Yeah. You can have either -1 times pi plus 1 or negative pi minus 1. The first guy, f and g, this is f prime, this is g. The derivative of cosine is negative sine. Then plug in pi, 2 cos of pi is -2. Negative sine pi times 2 pi is 0 because the sine of pi is 0. Okay. Next rule. What do we think? Is the derivative of 3x squared plus 6x plus 9 divided by 2x equal to 6x plus 6, which is the derivative of the top, divided by 2, which is the derivative of the bottom? No is the correct answer. Because we know if I wanted to take the derivative of this, I would first have to split things up and divide each piece by this 2x. And I hope we did this on our quiz. And then when I finally take the derivative, I get 3 plus 0 minus 9 halves x squared. Sweet. Okay? Not the same as 6x plus 6 over 2. Well, let's talk about the quotient rule and what actually it is. So, again, if you want to write just to make sure, the derivative of something divided by something else is not the derivative of the top divided by the derivative of the bottom. What it is a little bit more complicated than the product rule. However, it's a little similar to the product rule. Okay, it's going to be f prime g, g prime f, just like the product rule, only with a minus sign in between. And it's all going to be divided by the bottom squared. So instead of it, the derivative of the first times the second plus the derivative of the second times the first, it's the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom square. Now, your book and other sources use different formulas than I do. They use U's and V's, and when you're checking your work, you might be like, well, I got the same thing, but it's flip-flopped. It's okay. I like using this as opposed to the way the book does it, because you got f prime g, g prime f. Here, you got f prime g, g prime f. Now, guess what? I'm going to go over some examples while you're gone. You get to watch those examples and do your homework. Right, so let's do some examples. Find the derivative using the quotient rule. Now, notice this function can't simplify it like I could that example that we could earlier. This one I could divide everything by 2x. For this function x over x squared plus 1, I can't simplify it by dividing. It's just what it is. So to take the derivative of it, I'd have to first make sure I identify the top and the bottom, and then use the quotient rule. So here we go. d dx everything, you get f prime, which is 1, times g, which is x squared plus 1, minus g prime, which is 2x, times f. That's very important when you're doing this to be subtracting everything. In this case, it's not that important because it's just 2x times x. But if there's multiple terms, subtracting all of those terms are important. And then that's all divided by g squared, which is x squared plus 1 squared. And this is f prime. Now, this is a derivative. I could plug in values like 0 in to get derivatives. I get 1 minus 0 over 1. That's 1. So I could plug in values in for x to get slopes. So simplification of this is not necessarily important. However, you might have to simplify for a multiple choice question. And if you do that, you should probably distribute things in the numerator. It's usually not important to distribute things in the denominator because it's not necessarily going to help you. And then maybe combine the negative 2x squared and the x squared to be negative 1x squared. Yeah, 1 minus x squared. Okay? So that's what we could do to simplify. Now let's do this one. Same deal. Can't simplify it. I must use the quotient rule. This is f, this is g. I get g prime is equal to, and this is g squared down here. F prime g minus g prime f all over g squared. So that's the quantity x squared squared. Can you simplify this? Sure. Maybe you could pull out an x from the top. You got x cos x. Typically, we like to put the x's being multiplied before the trig function, so you don't get confused about where the x's are. And this would be minus 2 sine x over x to the 4th. Will you have to do that in your homework? No, you just have to be prepared to do it. And look, this cancels with this. This becomes x cubed. Let's do a couple others. Asking us to find the instantaneous rate of change of the function at x equals 0. X equals 0, this should be an x. So let's do this guy. Need to find the derivative of this guy at 0. That's the instantaneous rate of change. The same thing as the slope of the tangent, the same thing as the derivative. Well, you have to use the quotient rule. F, this is g. So let's do it. F prime would be equal to the derivative of the top, which would be negative 2 minus 2x times the bottom, minus the derivative of the bottom, which would be 2x times the top. I'll keep this all in parentheses so I know I'm subtracting everything. And that's all being divided by the bottom squared. Now, this looks like a mess. This is crazy. However, if I'm plugging in 0, it's not that bad. I get -2 times -1 minus, this entire thing would be 0, all divided by -1 squared, which is 1. So this would just be +2. Okay, so though it's a mess, though we can simplify it, I'm sure we can simplify it a lot. Sometimes we don't want to, because it'll just make things harder to work with. Let's look at this guy. We need to take the derivative of this. We'll have to use the quotient rule. That'd be big G prime of x. The derivative of the top times the bottom. I'm going to run out of room. Minus the derivative of the bottom. The derivative of -2 cos x would be +2 sine x times the top, all over the bottom squared. Now, it's important to put everything in the bottom in parentheses when you square it. Now, let's figure it out at 0. So G prime at 0, plug in 0, I get 0 minus, this would actually also be 0. Cosine of 0 is 1. I get -2 squared, which is 4. So the slope would be 0, but at least it's not undefined, which is good. Right, next question. Find the points at which the graph of the function has a horizontal tangent. We're used to this question, just not used to this type of function and finding when it has a horizontal tangent. But the same thought process and the same procedure applies. We're going to try to figure out when this has a tangent that equals 0. So how do we figure that out? We take the derivative to find your slope generator. We set it equal to 0, and we solve for x. So let's do it. I get 2x, that's f prime, that's the top, times g, the bottom, minus the bottom, derivative of the bottom is 1, times the top, all over bottom squared. Now, we're going to set that equal to 0. Now, here's where it's tricky. We're trying to figure out when a fraction with variables both in the top and the bottom equals 0. Well, turns out we don't really have to worry about the bottom. You could think about 0 as being 0 over 1 or 0 over any number. The most important part is this numerator. This numerator has to equal 0. And as long as the values that I get don't make the denominator 0, so I get 0 over 0, then I'm fine. I'll get a slope that's equal to 0. The problem becomes if I do have a value that I plug in to get me 0 in the numerator and it gets me 0 in the denominator, well, that means we're not necessarily equal to an undefined slope. It's probably that the derivative doesn't exist. That rarely happens, but it can happen. So another way to think about it is you want to get rid of this x minus 1 squared by kind of multiplying both sides by x minus 1. Now, don't necessarily do this because we still want to think about this as having a denominator. So instead, just really set the numerator equal to this 0. And then solve, and then make sure your values aren't any x values like 1, because if I get 1, I'll get a denominator that's equal to 0. So this is 2x squared minus 2x minus an x squared, which is equal to 0. Can combine my like terms. I'll get x squared minus 2x equals 0. I can factor out an x, giving me my two solutions at 0 and 2. At the x coordinates 0 and 2, I will have a tangent slope that's equal to 0. Both of those will not make the denominator equal to 0, so I'm good. Now the question, though, wasn't the x coordinates. The question was to find the points. Okay, so the points at which the graph, so the points on the graph. Now the points on the graph will also be the points on the tangent line. We just need to find those locations. To find points, plug them into your original function. So f of 0 would be 0 over negative 1, which is 0. F of 2 would be 4 over 1, which is 4. So that gives me the point 0, 0. I have a horizontal tangent. And the point 2, 4. I have a horizontal tangent. Next question. Find the position of a particle, the position of a particle is given by this function, x of t. Question is, what is the position of the particle when it is at rest? Probably when it's first at rest. But we'll see. Well, it's tricky, you know, we're dealing with position, and we're dealing with when a particle is at rest. This is the key word in this question. At rest means the velocity of my particle is 0. So I'm given position, I need to figure out when the velocity of this particle that has this position function equals 0. Well, we know that the derivative of position equals velocity. So, turns out this question, though it seems a lot different, is the exact same question as this. Really, we're trying to figure out when the function has a horizontal tangent, or when the slope of this guy equals 0. So, let's figure that out by taking the derivative of this. Let's go f prime g, so that's 1 times t squared minus 7 minus g prime 2t times f. I'll keep this all in parentheses. All over t squared. Now, when we want to set this equal to 0, again, we really don't worry about the denominator too much. Instead, we set the numerator equal to 0, and then make sure the values don't make our denominator 0, so that it's an undefined value. So I get t squared minus 7 minus the quantity of 2t squared minus 8t after distributing. I'll distribute this negative. Then I will get negative t squared plus 8t minus 7 is equal to 0. I will factor out a negative, or multiply everything by a negative 1. So we factor this to be t plus negative 7. And then t minus 1, or t plus negative 1. So I guess it doesn't have to be first at rest. It can just be when it is at rest, because we'll have two values when it's at rest. It's not like an infinite amount of values. So when t is 7 and when t is 1, my particle will be at rest. Its velocity will be 0. The question is, what is the position of the particle when it's first at rest, or when it's at rest? So now I have 7 and 1. I need to be plugging those into my position function to see where my particle is located. What looks like a completely different problem ends up being the exact same as the previous problem we did, just with different terminology. And of course, 7 and 1 can be plugged into my denominator. It won't make it 0, won't be undefined. So I have 7 minus 4 over 7 squared minus 7. That's 3 over 42. 49 minus 7, 42. That is 1 over 12. 1 over 14. Yeah, 1 over 14. So there's 1 point. And then find the other point, plug in 1. I get 1 minus 4 over 1 squared minus 7. I get negative 3 over negative 6, which is 1/2. So there's your point. There's your x-coordinate and your y-coordinate, your position. Here's your time. Here's your position. So at 1/14 and positive 1/2, this particle would be at rest. Next to last question, find the equation of the line normal to f of x when x equals 0. Now, normal is perpendicular. So if I find the slope of my tangent, that'll be equal to the opposite of the reciprocal of my normal slope. Okay, you can go vice versa with that. So all I need to do is find the slope of this tangent line at 0, take the opposite reciprocal of it, that'll be the slope of my normal line. So let's do that. Let's find the derivative. It would be f prime times g. F prime is 1 minus g prime, that's 1 times f, all over g squared. Now this can simplify, but maybe we don't want to because I can just plug in 0. I get 6 minus 1 over 6 squared. That is 5 over 36. So this is the slope of my tangent line. I need the slope of my normal line. Now, a normal line, if we think about this, if we think about some graph, a tangent line will look like this. A normal line will go through the same point. It'll just be perpendicular. So it'll cross through my graph at the location that the tangent touches my graph. It'll just be with an opposite reciprocal slope or a perpendicular slope. So I have the slope. I just flip it and take the opposite of it, and this is my normal slope. Good. Now for my equation, I need this slope, and I also need a point. Point always comes from my original. It'll tell me where my tangent line is passing through. So f of 0 would be equal to 1 over 6. So I have my equation, y minus y1 is equal to this normal slope times x minus x1. Okay, simplify this if you want to. Finally, last problem. Given the position, find the exact velocity of the object when t equals 1. Of course, these should all be t's. All right, so we have position. We need to find velocity at 1. I know the derivative of position is velocity, the instantaneous change of your position. So we need to be looking to find v of t. Now notice, yeah, we have a quotient. Did I mess it up? Let me make sure I didn't mess it up. Yep, there should be a t down there. We have a quotient, and we can take the derivative, and we get some. However, what's very, very important is that something might be easier to be done if you simplify it first. So I give you this example because in class I would want you to spend 5 minutes finding the derivative of this and then plugging in 1. But while you were doing this, I would be like, well, look at this. We got negative 9t plus 6t squared over 7t. And I can divide both of these, because I just have one term at the bottom. I get negative 9/7 plus 6/7 t. And while you were still working, I would say, oh, I got my answer. It's 6/7. Because the derivative of this is just 6/7. Take the derivative of this guy, d dt, and this is 0, and this is just 6/7. So no matter where my object is located, the derivative is just 6/7. You would find that out if you took the derivative of the guy using the quotient rule. But this is just an example to say, hey, look to simplify first before we go jump in and do the product or the quotient rule. Especially when you know you can simplify it easily. There will be some functions like the previous ones, like this guy. This is not simplified really nicely, you know? It'll just take a while to do that. Whereas you can find the derivative and then plug in values, and that's easy. Okay? All right. Good luck on the homework, and I'll see you next class.